Evening, everyone. Welcome to this channel named Geeks for Geeks School. And today we are going to develop a very beautiful 3D animation with the help of Python coding. And we guys will be using Ursina for making that 3D kind of animation, 3D animation, right? So let's first start with importing all the required modules, the libraries which we will be requiring for this 3D animation. That's what I would like to import first. So the first library is this Ursina's library. From Ursina, import asterisk because I want to import everything from Ursina. That's the reason I am using this asterisk over here. Let's import the numpy also. So I'm importing numpy, or you can call it as numpy or numpy as np. So np is an alias name I have used over here. So wherever this numpy is required, now I can put np in order to use this numpy. I don't have to use this full name, right? Simply I can use np in place of numpy. Let me just save this code. So I'm saving it in a folder which I am creating right now, in the folder in which I have all my Python libraries and files. So 3D animation is the name I am giving to this folder, and I am saving it with solar.py. Fine. And okay, done with saving this much of code. It's time for us to define the basic structure of Ursina. So Ursina, and then we can put these brackets. And then let's create a sun in the center. So for doing that, we guys can use this entity function, right? Let's assign sphere as a value to this model. So the color of sun is, of course, yellow. So I would like to assign this value yellow to this color attribute, and let's now define a scale for this sun. So it should be of 1.5 at least. Okay, it's time for us to define the code with which we can run this Ursina, and that's the function run, with the help of which we can run Ursina and get to see the display window of Ursina. Let me just save the changes, and now if I will build it on Python, let's see what are we going to get. It's going to take a bit of time, no problem. So thing right now, so it's a yellow color circle thing we are getting at the center, and we are getting this display of Ursina. Fine, it's so this code is working perfectly fine. So what we are here for, we are here for developing a 3D solar system animation. I hope you guys know very well about it. So in solar system, we have a sun and we have 9 different planets. It's time for us to define the code with the help of which we can create all the 9 spheres. Right, so what I am doing, the way I have created the sphere for this sun, I am going to use the same code for creating the 9 planets also. So I am copying and pasting it 9 times over here. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Fine, so the first one is, of course, Mercury, and model is going to be sphere, perfectly fine. Let me just change the color of this sphere to gray. So Mercury is going to be of gray color, and I would like to change the scale to 0.2. Then after this Mercury, we can have Venus. Model is going to be sphere, and color, let's make it orange. So we are going to have different colors for all the 9 planets, all the different 9 planets. Let me change the scale to 0.3. Sorry. Third one is Earth, and color is going to be, of course, blue. 70% of Earth is water, right? So that's the reason I've chosen this blue color. And let's give it a scale of zero point 0.3. Okay, I think zero point 0.3 will be fine, or let's make it zero point 0.4 because zero point 0.3 we have for Venus, right? Then after Earth, we can have Mars, and let's have violet color for Mars. So I'm changing it to violet. Let me change the scale of this Mars to how much shall I define over here? So I'm making it zero point 0.3. Jupiter is going to be a little bit more broad. So first of all, let me just define the color for Jupiter. So I would like to have a white color for, oh, not white. So let's make it red. I think red is going to be a good option. Instead of 1.5, let's have 0.6 scale for Jupiter. Then after Jupiter comes Saturn. Right, entity is going to be model, sphere, fine. For this color part, let's pass white. Right, and for this scale, for Saturn, we are going to have this 0.5, and then comes Uranus, right? Just a second, Uranus, and I'm going to have a cyan color Uranus. Okay, and then we can have 0.5 scale for Uranus. Now, the second last one is Neptune. The last one is Pluto. Okay, for Neptune, we can have this gold color, and for Pluto, we can have a pink color. Let's define a scale of 0.5 for Neptune, and for this Pluto, you can have a scale of 0.2. I think that is going to be a good idea. Now, if I will run this code, so I will not be able to see the other planets because the circle is hiding the other planets right now. Okay, that's the reason the others are not visible to us. Let's close the window, and here I would like to define a variable, a counter variable. So let's assign it this value np.pi. So pi is for pi, right? I hope you guys know about it. So np has this function named pi, with the help of which we can access the pi value. Okay, and let's now come up over here right after this point where we have imported this numpy module. We can define the update function. So whatever you are going to put inside this update function, it will be called for every frame. It will get updated for every frame, right? I hope you guys know about it. If you don't know about this update function, I would request you to please check out the previous lectures I've shooted for this Ursina game engine. Right, it's an amazing game engine with the help of which you can create both the types of games, 2D games also and 3D games also. But for 2D, I prefer Pygame over Ursina, and for 3D, I prefer Ursina because it's amazing. Fine, it has all the what we call it features and all the facilities that we can use for creating amazing and interactive 3D games. So for every frame, what is going to happen to the value of t? So because it's global, so that is the reason it can be called anywhere in this program. And then t is equal to t plus 0.02. So for every frame, the value of t is going to be different, and it will get incremented by 0.02. Fine, and then we can have an angle of, let's say, np dot pi. So pi into 40 by 180. Fine. So this is another variable that I have used here. Then we can have another variable with this name radius 1 is equal to, and I would like to initialize it with this value 1. Right, let's now define the code for making the Mercury planet move around the sun. How can we do that? It's very easy. We just have to pass this code Mercury dot x, because we want to see it moving along the x and z axis simultaneously. So for this x axis, you can use this simple code cos time t, and then you can multiply it with radius underscore 1. Same thing you'll have to do for the z axis also, so you can change it to z, and for this z we can have sine in place of cos. Let me now run this and show you the output. So that is what we are getting as an output. This is the Mercury, planet which you are able to see revolving around the sun. I hope you're liking it. This is a very good animation which you are seeing right now over here, right? Okay, if you want to see it from some other angle, suppose, so you can change the position of the camera. I hope you guys know about this code. So camera dot position, and let me make it 0.056, 0.56. Now if I will run the code, let's see what's gonna happen. Okay, so this is the view which I'm getting right now, and if I'll change it to 0.56, so that's how you can just change the angle of the angle of your camera and reposition it. Let me make it zero point 0.1. So you can just play with this camera dot position, right? So not able to see anything because camera is not able to capture the objects which are there on the display window. Maybe that's, so this is what I'm able to see right now. Okay, and if I'll pass minus zero point 0.4 to this camera dot position, let's see what's gonna happen. So right now nothing is visible to us. Okay, let me tell you one more thing. If you want to rotate your camera, it's camera dot rotation. So you can rotate your camera along the x-axis also and y-axis also. Suppose you want to rotate it along x-axis, so rotation underscore x, and then you can pass an angle through which you would like to rotate the camera. And the whole thing will change now. The moment you'll comment it out, so this is what you will get now as an output. We're able to see the sun as well as this planet moving, but the moment you'll remove it, and let me just pass a negative value to this 30. Okay, okay, so I'm not able to see anything right now just because the camera is not correctly positioned. So with the help of these attributes you can play with the camera's positions. Fine, let me come up, and we are able to make the Mercury planet move around the sun. It's time for us to make the other planets, the other 8 planets also move around the sun. So the only thing that you have to do for this is you can copy this entire thing, right? And you can just have to place it here. Fine, just put it here, and then you can change this to 2. Okay, so for Mercury, we can have a radius of 1.4, and then, sorry, it's for, what is the name of the second planet? It is Venus, right? So we can replace all the Mercuries with Venus. So Venus, and then here also we can put Venus, and then here we'll have to put 2. So this radius over here is the radius of the orbit in which the planet is going to revolve. Right, so the radius of the radius of the orbit in which Mercury is revolving is 1. The radius of the orbit in which this Venus will revolve is 1.4. Why the radiuses are different? Because every planet is going to have a different orbit, right? We don't want anyone to overlap with each other, so that's the reason. We do not want any planet to overlap with some other planet, so that's the reason we need to have different radius for different orbital radius for each of the planet. We have defined over here the code for, so np dot cos t, and we have multiplied it by radius underscore 2. This is perfectly fine. Now here we have to do one more thing. So we cannot pass the same value for the cos and sine over here, the one which we have passed over here. We cannot pass the same here also, so we'll have to change the value. I would like to add the angles value, this variable's value to this t over here. Okay, so I think now the output we are going to get is going to be perfectly fine. Let me run this game and just check out the output. Okay, so we are able to see both the planets, and you can see how beautiful the animation is looking, right? So we both the planets are visible, the sun is also visible to us. Great. Okay, let me do the same thing for the other planets also. It's time for us to copy this code, and I'm going to repeat the same steps. So replacing this with radius 3, sorry, and let's change it to 1.8. Then we can have it is for the Earth, right? So Earth, we can replace all the Venus with Earth, and let's multiply this angle by 2 because we are going to have a different angle for the Earth. And then we can change this to 3, right? Okay, let me save the change and press Control and B together. Okay, I need to put 2 over here. That's the reason I'm getting this error. We are able to see this blue color Earth also revolving around the sun, and it's looking beautiful, isn't it? Okay, so if you really like it, please do share this video in your groups so as to or make it reach to the maximum students possible. I would like them also to come and join this channel and enjoy this beautiful coding classes I'm providing on this amazingly awesome channel named GeeksforGeeks. So it's time for us to define the code for the fourth planet, which is Mars. And here we can simply change it to 3 because angle should be different for each and every planet that we have defined the code for here. So this is for Mars. Let me run this program and see what are we going to have as an output. Okay, so we are able to see all the 4 planets, and they see how beautiful they are looking. Okay, that is perfectly fine. Need to now repeat the same steps for getting this Jupiter also revolving around the sun. So simply after this Mars, we can put this Jupiter. Here also we need to replace it with Jupiter, and we need to replace this radius also. So I'm replacing it with 2.6. I think 2.6 is perfectly fine. So this is radius 4, this should be radius 5, right? 2.6, Jupiter, and then here we can have 4. Okay, and here we need to have radius 5. Let's make it 4. Let me see the changes, and sorry, Control and B for running the code. Okay, so that is what I'm getting as an output right now. See, it's a 3D animation which we are able to see right now over here on this beautiful Orsina window. Okay, that's great. Let's copy this whole thing, and I would like to now again repeat the same steps. It's time for us to change the value to 3. Okay, and then we can change the name of the radius also. Radius 6, radius 6, and here we need to change it to 5. What is there after Jupiter? It is Saturn. Fine. Let's change it to Saturn. Then Saturn. Okay, running the code. Okay, so Saturn is also there, right? Okay, that's looking beautiful. Okay, repeating the same steps for the other planets also. So it should be 7. Here also it should be 7, 7, changing the radius to 3.2. And then we have Uranus. Uranus, and this also we need to assign Uranus 6, 6. Saving the changes. Again, copying the same code and putting it here twice. Radius 8, radius 9, and this should be 7, 8, 7, 8. Okay, this should be 9, 9, 8, 8, and we have Neptune and Pluto. So Neptune, here it should be Neptune, and here it should be Pluto, and here also it should be Pluto. So we are playing with X and Y, X and Z axis right now. Okay, 8, 9, 8, 8. This is perfectly fine. Okay, and this should be 3.4. I think rest everything is going to remain the same. Let me save the changes and run the code again. So we are able to see all the 9 planets now on this window, and they all are revolving around this yellow sun. Okay, so it's looking amazing right now. And let me just check the comment box. If I have anything to answer, we would like to answer those queries first before moving to the next part. I hope you're enjoying this video, all of you. Do let me know if you have any queries regarding to whatever we have covered till now. Okay, so I am on the comment section right now. Not able to see any queries in the comment box. I hope everything is clear to you guys, whatever we have covered till now. Fine, let me do one thing now. Let me try and play with the camera's position. Okay, so for this, let's come down, and here I would like to define the, okay, let me do one thing. Let me just come down over here. So camera dot position equals to, let's make it 12. And if I will now run this code, let's see what's going to happen. Not able to see anything. 1.2. Just want to check out, the solar system with a different angle. Minus 1.2. Let me just remove this and rotate the camera along the x-axis. So if I will put a positive value here, okay, so it just went up. Right, earlier it was getting reflected in the center, and it just went up. And if I change the y by 4, okay, so it shifted here. And if I'll change the z by 4, so that's how you can rotate the camera. Okay, so it is now tilted. And if I will change it by, let's say, 20. Okay, so that's looking much beautiful, right? So this is how you can keep changing the position. Okay, I would like to now change the position. No, I would like to rotate the camera now along both the axes, z as well as x. So if I will do it like this, let's see what is going to happen to the view of the solar system. We are not able to see anything, right? Let me change it to -20 then. Nothing is visible to me, and if I will change it to -2, so this is what is visible to me right now. Let me now rotate the camera along all the y-axis, all the three axes together. So now what will happen? Let's check it out. Okay, okay. And if I'll go by, I have to shift the camera on the top of the solar system. So for doing that, nothing is visible to us. Okay, so this is what we are seeing right now. We are very close to the planets which are revolving around the sun, and we are able to see all the planets like this coming down. Fine, that is a very good view. Let me change it to 0.01. Now, if I will run the code, let's see what's gonna happen to the view. Okay, if I'll change it to -0.01, so not much difference. That's how you can, do some experiment with the, see, now they are going like this. We are able to see them moving horizontally now. Right? They are rotating around the sun. We are not able to see the sun right now just because we have positioned our camera in that way that we are able to see only the front view, but the sun is not visible to us because the camera is behind the sun. Not much difference. So that's the way you can play with the position of the camera, and that's the way you can rotate the camera and position it wherever you would like to in order to check out the view from the different angles. I hope you guys enjoyed this one a lot. Please do not forget to like and share this video. Before ending this meeting, I would like to show you the whole code again, with the help of which you can create a very beautiful 3D solar system animation. So that's the whole code, right? This is the whole code which I have used for creating the 3D solar system animation. Let me run this code again so as to show you what is the output we are getting. So that's the output we are getting right now. Just because the camera is positioned in this way, that's the reason we are not able to see the whole solar system in this on this display window. If you want to see the whole solar system, you can just remove this line of code from here. Let me close this window, save the changes, and run the code again. So I think now we'll be able to see the whole solar system. So see, uh, so these are the 9 planets which you are able to see, and they are of different colors, as you can see. In the center, we have this sun of yellow color. And if suppose you want to change the color of this window, definitely you can do it with the help of window.color, of course. Right, I have told you everything about Ursina in the previous lectures. So if you don't know about Ursina, you want to know more about Ursina, you can check out the previous tutorials which I have shooted on this beautiful channel named Geeks for Geeks School. And before leaving you guys, just want to tell you that there are going to be more lectures which will come up on this channel now. There are many more lectures which are still to come up on this game development with Python. So if you want to get the notification of those meetings which we will be scheduling on YouTube, on our YouTube channel named Geeks for Geeks School. So please don't forget to subscribe the channel and hit the bell icon. Definitely, we'll shoot it. We'll give you all the beneficial tutorials. They are going to benefit you a lot. They will be very entertaining for you, and you are going to gain a lot of things on this channel. So don't leave the channel, be there, and we are going to come up with some fresh content very soon. Okay, so thank you very much and have